Hi everyone, so we're going to be doing today adding and subtracting integers. This is a review topic for the 7th grade. Here we're looking at the nested chart with our rational numbers. So we see that natural numbers are a part of whole numbers are a part of integers, and integers are a part of rational numbers. Our vocabulary terms: rational numbers, any number that can be expressed as a ratio of two integers. And integers are defined as the set of whole numbers and their opposites. So if we look at the box containing integers, we'll see that it does include our whole numbers, 0, 1, 2, 3, 4, and so on and so forth, and the opposites of those numbers. So -1, -2, -3, -4, and so on. So here's a really cool song that I really enjoy using to help with remembering the rules for adding and subtracting integers. The song is: same signs, add and keep, different signs subtract. Keep the sign of the higher number, then it will be exact. So let's go ahead and take a look at these 4 examples that are outlined here. So when I look at the first example, I want to take into account the words of my song. Same signs, add and keep. So if I look at example 1, I'll notice that both of these numbers have the negative sign in front of it. So both of them are negative and they're being added. So following the rule, I'm going to stack my numbers. 3 plus 9, which is 12. So it says to add and keep. So we're keeping that negative sign. So the final answer here is -12. Now for example number 2, we notice the same thing. Both of the signs are the same. Here we can identify that they're positive. If there's not a sign in front of a number, we can draw the assumption that that number is positive. So I'm going to go ahead and stack these just like I did before. Be sure when working with decimals, you remember the rules for adding decimals. You should have your decimal points carefully lined up. And I'm going to put a 0 here as a placeholder just so I do not become confused. So 5 plus 0 is 5. Then I'm going to bring down my decimal point. 4 plus 3 is 7, giving me a final answer of 7.5. Both of these examples, 1 and 2, follow the rule of same signs, add and keep. Now let's take a look at example number 3. Example number 3 says 5 minus 8. Here we can see that the signs are clearly different. If I were to write in the sign for 5, I would write that it's a positive. Because if there's no sign there, then again, I can draw the assumption that it is a positive number. Whenever we follow the rules for subtraction, we know that our larger number will be written first, and we're subtracting the smaller number from it. So 8 minus 5 is 3. And then here it says different signs subtract, keep the sign of the higher number. The higher, or we can even put in the word larger. Either of those are synonymous. So the sign associated with the 8, which is the larger of the two numbers, is a negative, so I can put that here. So my answer for 5 minus 8 is -3. Oops. There we go. Now for example number 4. The same concept applies. I have a -3.25 and a +7.5. So I'm going to go ahead and stack my numbers. Different signs again, so I'm subtracting. And if you notice, I'm still following my rule for when I am adding or subtracting decimals. I'm ensuring that I line those decimal points up. I'm going to put in a placeholder here. Okay. And I know I have to borrow, so I'm going to go ahead and apply my rules for subtraction. So 10 minus 5 is 5. 4 minus 2 is 2. Bring down that decimal point. 7 minus 3 is 4. for a final answer of 4.25. Now let's see if this is negative or positive. Keep the sign of the larger number. So 7.5 is clearly larger than 3.25. So this is a positive. I do not need to write the plus sign because not having a sign denotes that it is a positive number. Okay. So now here we have, for example, if you notice that the numbers in these two examples are the same, and the same applies here. However, there are some differences in the sign. This is a good place to pause the video and try these problems on your own, and then reference my answers. So here I have different signs. Okay, I'm sorry, here I have same signs. So negative 2.9, negative 13.4. So this is going to be add. Okay, let's go ahead and do so. Okay, so if you notice, I'm stacking my numbers and I'm still keeping in mind my rule for adding decimals. 4 plus 9 is 13. Carry the 1, bring down that decimal point. 3 plus 2 is 5, plus 1 is 6. And then I bring down the 9. So here I have 16.3 as my answer. But am I done? No, I'm not. Same signs, add and keep. We want to keep that sign. And the sign that's associated here is a negative, so I'm going to put that in. So my final answer is negative 16.3. Now let's look at the other example where the numbers are the same, but the signs are a little bit different. So here I have a positive 2.9 and a negative 13.4. So if I have different signs, because this is in essence a positive, then I know I need to subtract. Okay. So 13.4 minus 2.9. Here we need to borrow. 14 minus 9 is 5. 2 minus itself is 0. And then we bring down the 1. Okay. It says different signs subtract. Keep the sign of the higher or larger number. So here we see that the 2.9 is a positive and the 13.4 is a negative. If I think about this as money, I know that having $13 is way more money than having $2. So 13.4 is clearly a larger number than 2.9. So this is going to be a negative 10.5. Okay, this again is another good place where you can pause and try the next two examples on your own to see how much you have mastered. Okay. So again, same signs, we're going to add. Seven and 5 is 12. Bring down my decimal. 9 plus 1 is 10, plus 1 is 11. Same signs, add and keep the signs. If you notice, I keep referring back to the song because it's really a useful tool in remembering what to do. 11.2. Okay, let's try the next one. So here we have different signs, so we're subtracting. Seven minus 5 is 2. 9 minus 1 is 8. Keep the sign of the larger number, which happens to be positive, so that will stay positive. All right. Thank you for watching. Have a great day.